Hello everyone, welcome from my side to the Spring Framework 3.2 webinar. This is a bit of an unusual webinar for us since we actually have 3 presenters today and decided to structure the webinar in a slightly different way. So we'll kick things off with an introduction, Spring Framework 3.2 overview, but we'll actually have a dedicated section on Spring MVC updates presented by Rossen and a dedicated section on community and contributions, a particularly important aspect of every open source project that we've also been focusing on. So quite a bit of the stuff that we've been working on lately is actually related to project setup, build systems, GitHub, community contributions, and so forth, and you'll hear more about that. At the very end, I'll be returning for an outlook, basically talking about 2013 and the plans that we have. We've been publishing our Spring Framework 4.0 plan yesterday as a summary, and I'll basically be presenting this plan to you, and we'll have a chance to discuss it. All right, let's go back to Spring Framework 3.2. 3.2 is an important release from our perspective in that it concludes the 3x line from our perspective. Basically, Spring Framework 3.2 delivers on the promises that the Spring Framework 3 line started, including configuration classes, including REST support all across the framework, in particular the fine-tuning that's always necessary with any such work. And we've also been doing quite a bit of further work towards Java 7 and a couple of areas in the core container. So you can see an overview where I've just been summarizing a couple of work categories. We have a new Gradle build now that might be interesting to the ones actually contributing to the project, but it's also interesting for us in that we have just a completely different degree of flexibility in structuring our project. We've been working on a couple of core container areas, and I'll be going into more details in a second. We've been doing plenty of web-related work and plenty of runtime refinement work. I won't be talking about the runtime refinements in much detail, but we always do spend significant time in fine-tuning runtime characteristics such as performance, locking behavior, of course also the use of memory. Spring Framework 3.2 has a particularly significant amount of work, have seen a lot of work in that area. So you'll experience, in high load scenarios, you'll experience just different core container behavior in terms of the use of locking. But let's go back to the major themes. Our Java 7 theme has really been taken to a conclusion in Spring 3.2 because we've been introducing Java 7 support in Spring 3.1 pretty early after the release of OpenJDK 7. However, at the time, we've been building on Java 6 and basically just in quotes, introduced support for the dedicated Java 7 level in terms of APIs, JDBC 4.1, the here mentioned fork join pool, a couple of a bit of fine-tuning work in Java 7's reflection. The work has been continued in Spring Framework 3.2. We're actually building on OpenJDK 7 now. Our test suite runs on Java 7 now, where we've had plenty of fine-tuning in terms of the order of execution of tests and so forth. There's quite a bit of special behavior in Java 7, let's put it like that we've had to accommodate in one form or the other. We've also retained compatibility, of course, with not only Java 6, but also Java 5. So we're still building in a Java 5 compatible form. Nevertheless, Spring Framework 3.2 represents the generation of the Spring Framework that is really fully designed and optimized for Java 7. as part of that work, we've also had to upgrade ASM and CGlib, both of which, fortunately, had new major releases that fully support the Java 7 bytecode formats. You probably won't have experienced any issues in that respect. It's primarily related to the use of invoke dynamic, a new instruction in Java 7's bytecode that the processing libraries ASM and GitLib have to be able to deal with, even if that's hardly used in practice yet. We've performed an upgrade for Spring Framework 3.2, and at the same time, we've decided to inline not only ASM, but also GitLib. So both of those libraries are used in a repackaged version that basically doesn't conflict with anyone else's version of ASM and GitLib in the class path. We've been doing that with ASM before. We're doing it with GitLib as well now in the most recent versions. Particularly favorite of mine is the use of meta annotations all across the framework. It's a line of work that we've spent a lot of time on in Spring Framework 3.x. So you've basically seen quite an evolution of this here. Most of it has been started in Spring Framework 3.0, but one particular feature has been introduced in Spring Framework 3.2 here, completing the picture from our perspective. And it's the use of injection annotations and bean definition annotations as meta annotations. So what you can see on this slide here are basically custom injection annotations of different sorts. My auto-wired is basically a custom version of an injection annotation that's meta annotated with add auto-wired, Spring's standard add auto-wired. And for example, just as an example, meta annotated with a specific qualifier. Basically, you're shortcutting add auto-wired with a specific qualifier into a custom annotation of yours. An annotation where you are actually able to choose the name. So I would not recommend my auto-wired. I would actually recommend choosing a name that makes sense within your architecture, within the module that you're in, that kind of represents the combination of semantics that you're specifying as meta annotations. As another variant of this, consider the use of add value. The MyPort annotation shown here uses add value with a specific expression as a meta annotation. So it's basically a shortcut for the longer-winded add value plus the system properties.myport expression. This is actually a variant that allows you to build type-safe annotations for specific properties, for specific configuration settings, for example, in your application, if you prefer to do it that way. It's particularly, it makes sense if you repeatedly refer to the same properties, for example, if there's a limited number of those in the first place. If you find yourself repeating the same EL expressions all over different components. And that's one way of addressing this problem. And the third one here is actually a bean definition annotation. It uses @bean as a meta annotation. So you may use this custom mybean annotation here in a configuration class of yours, where instead of saying @bean, @myQualifier, @lazy, you're just saying @mybean, basically as a shortcut for @bean with that specific qualifier, and with additional semantics such as lazy, primary, a default scope, and so forth, that you may want to bake into this specific annotation. That makes a lot of sense if you find yourself repeating the same qualifiers, the same default scopes, the same lazy annotation maybe, all over a configuration class or several configuration classes in your system. So we basically completed the picture in terms of composable annotations, the use of meta annotations in order to build custom annotations that provide the most concise and most expressive version of an annotation in your application architecture. So it's really a tool for an application architect to design specific annotations for a specific project, for a specific module in a system, that's appropriately named and has appropriate default characteristics baked in. As a further line of work, we are tracking upcoming specifications that have just a strong relationship with what we're doing. And with the cache abstraction that we introduced in Spring Framework 3.1, we basically didn't have any kind of specification to work against. We designed our cache abstraction with an upcoming standard in mind, though. And this standard, called JCache, JSR 107, is actually emerging now. So there's a JCache 0.5 draft that we've been working against, and there's initial support for JCache backends, JCache compliant cache managers as a backend for Spring's caching support. We decided to release it in Spring 3.2 already, despite the JCache specification not being final yet. It's going final sometime later this year in time for Java EE 7, and you'll find full JCache support in Spring once that specification actually is final. You'll find further enhancements, actually, as a side effect of this work. You'll find further enhancements in Spring's caching support in 3.2, in particular in the EH cache support. We're trying to keep the standard JCache support and the EH cache support in sync as much as possible, so that native EH cache support remains a good choice for a backend in Spring's cache abstraction, fully capable with everything that you could also do with JCache. All right, so much for a couple of work areas that I just wanted you to brief on. Feel free to dive deeper if you're interested. I'd like to hand over to Rossen now. Rossen will introduce you to the plenty of changes in Spring MVC, plenty of refinements in Spring MVC that we've been doing for 3.2. Rossen?
Thank you, Juergen. As was already pointed out, Spring 3.2 had plenty of new features that we can talk about in the area of Spring MVC. And the most notable change that we're going to start with is the support for Servlet 3 async requests. And I will take a brief moment to explain what the async support is, how it actually works very briefly, as well as why it is helpful. First of all, what the async support is, it allows the separation of processing from the Servlet container thread. I think it's a well-known fact that in the Servlet world, the processing tends to be one request per thread. And it is actually quite common these days to have processing that continues longer. And for that reason, the thread pool of the Servlet container can be exhausted very quickly. So the idea is that an application using the raw Servlet API can use the request to request start async, and after that it can exit the container thread. The response in the meantime remains open. So even though we've exited the servlet and we've exited the filters all the way out, the response remains open, and we can continue to do computation in another thread. And once the computation is done, we can perform a dispatch back into the container in order to finish processing. And a dispatch is actually a new concept, but is very similar to a forward, except it happens from a non-servlet container thread. We can request a dispatch, and then we continue by starting the request over going into the servlet, and then through the filter chain and the servlet and so on. So why this is useful is because it provides support for long-running requests. For example, the long polling technique can be implemented in this way, and that allows for increased throughput. To be clear, the async support is not going to make a request more performant if you simply compare one request which is asynchronously executed versus another, but in a scenario with long polling and long running requests, it can bring about increased throughput. Now, the Servlet 3 async support within Spring MVC basically means that we have two new controller method return values. The first one is Java util callable, and the meaning of that is that the controller that usually returns some kind of a value which is then interpreted by Spring MVC. So, for example, the controller could return a view name, or it could return an object to be written to the body of the response, could return a model in view, and so on and so on. Now the controller can return a callable, and the meaning of that is that the callable will be used to obtain the return value by using a separate thread, a non-servlet container thread. The second option is to return a deferred result, and deferred result is kind of similar to a callable, but the opposite in the sense that whereas with a callable, Spring MVC will call the callable to obtain a result, with a deferred result, the application can choose when to set the deferred result and from which thread. So that turns the threading model around, allowing the application to provide the final result for the controller method return value from any thread of its choice. So let's take a look at an example. In this slide, you can see a before and after with the Java util callable return value. Before, we're simply returning a string which is written to the body of the response, and we can change that to be a method that returns a callable, and the callable in turn returns the actual string after presumably performing some sort of a long-running database job or a third-party REST API call, which can take a while to complete. And the idea here is that we're exchanging the servlet container thread. We're exiting the servlet container thread to make sure that other requests can come in and be processed, and exchanging that for a thread which is managed by Spring MVC, in effect using a more specialized thread pool. For example, focusing on specific areas where database requests may be longer, or we may be making calls to a third-party REST API, and we don't want to hold up the servlet container thread. Those are the scenarios in which it makes sense. And this can be done with any return value type for Spring MVC controller methods. With a deferred result, we have the ability to, essentially the controller will create the deferred result by simply instantiating it, and then save it somewhere, perhaps on a queue or any sort of collection or map structure, and return the deferred result. And the act of returning a deferred result effectively indicates that we want to continue processing from another thread. And you can see in the second section of this slide that from some other thread, in this case, this is a scheduled thread, which kicks in at a fixed rate of every 2 seconds. We're going to go through the deferred results which are saved in our queue, and we're going to set them to some kind of a result. This is, of course, just meant to give you sort of an idea of how the application now has control over which thread it can choose to provide the return value from. But you can imagine here that this can be done in response to a JMS event or AMQP event, Redis notification, some thread which is not under the control and is not known to Spring MVC, just gives the application the opportunity to do that from any thread. And this can be used to implement a technique for server-side push The technique is called long polling. And I have a link at the bottom of this slide where you can read in more detail about real-time update techniques if you're not familiar with long polling. I will explain it briefly. A browser is going to send a request, and then the controller method is going to return deferred result in order to start asynchronous processing. The servlet container will exit the thread, but the response will remain open, and meanwhile the client continues to wait, the browser. Then at some point an external event takes place, for example a JMS event or AMQP Redis notification, and in response to that event we're going to set the deferred result, which is going to cause Spring MVC to dispatch back to the servlet container so we can finish processing with the provided value. So that means that we can continuously poll in this way and avoid polling immediately all the time in order to get a result, but we can wait until a result becomes available, which can significantly reduce the number of requests, of polling requests. And this is a very common technique. This is the most common technique today on the web for providing real-time updates. Now, in order to get Servlet 3 asynchronous processing working, there are some configuration bits which I will mention here, but you can read more about it in the Spring reference documentation, as well as if you become familiar with the Servlet 3 async API. Essentially, the servlet and all filters must have the async supported flag, which has to be done either through the WebXML on the servlet and on the filter mapping, or it has to be done through the servlet context when registering if using the Servlet 3 API for Java-based registration of servlets and filters. Also, on filters, the filter mapping has to include the async dispatcher type. If that's not the case, the filters will not be involved during asynchronous requests. So all of these things need to be in place before you can start using this. And here you will see some resources, some further resources about Servlet 3 asynchronous processing. There's a blog post series. There are samples that you can see that are referenced from the blog post series as well, and there is reference documentation. There's also a convenient base class. For those of you using the Servlet 3 API, there is a convenient base class for initializing Java-based, using Java-based configuration, a dispatcher servlet with root configuration classes and servlet, dispatcher servlet configuration classes, in this case using all Java. And then specifying the servlet mapping and also potentially customizing the registration to enable async supported. So that minimizes the amount of configuration that I showed you on one of the previous slides. Next, beyond Servlet 3 async support, we can talk about content negotiation. There's been some amount of work done in this area to consolidate the way that these options are configured. So for example, if you want to do content negotiation, you have to find out what kind of content type is being requested by the client. And that can be done in one of several ways. Obviously, the accept header is the preferred way to do it. However, browsers tend to send quite a different range of headers, accept header values, making them not very reliable in terms of trying to determine what content should be served, in which case file extensions are actually much more pragmatically usable. There are other strategies like request parameters, for example. So what this is about is the ability to configure all of that content negotiation for requested media types, whether it should be by file extension, by accept header, request parameter, what kind of default value should be used as a fallback, as well as plugging in any custom strategies you want throughout Spring MVC. So essentially, you can choose which strategies should be used and in what order and that can be configured once through the MVC Java config or the MVC namespace, which, by the way, automatically register the .json and .xml extensions if the appropriate libraries are available on the class path. Of course, if you're not using the MVC Java config or MVC namespace, you can configure directly the Content Negotiation Manager property on the handler mapping, the handler adapter, and the exception resolver. And you can use a Content Negotiation Manager factory bean if using XML-based configuration. That should help to simplify the way this is configured. For those of you who are familiar with the Content Negotiating View Resolver, that provided all of these options for quite a while now, since version 3 of the Spring Framework. However, these same options were not available, for example, with @response body methods, and that's what this is about. This is essentially making all of these options available throughout Spring MVC, configured from a single place. And they open up interesting possibilities for customizing the requested content type in various ways. So, for example, sometimes when processing exceptions, you might want to enforce that the content type requested is always interpreted as application JSON. That may be one way where you can plug in a custom strategy. Another use of custom strategies is if your application accepts XML and JSON, serves XML and JSON content, if none of these is requested, you might want to select what should be the default content type that will be served. So that's another useful way for configuring all this. And there are further options as well to plug in a custom strategy and to do something more with it. The next subject is REST error reporting. We've done a few improvements there of interest. So with REST, with HTML-based applications where we serve content to browsers for consumption by people, it is actually relatively trivial to plug in a single error page that will handle pretty much any exception in Spring MVC. That's done with the simple URL mapping, simple mapping exception resolver. However, when building a REST API, typically exception handler methods are more convenient. And the reason is because we can write to the body of the response, and it's very common for REST applications, REST-based applications, to provide details in the body of the response. However, exception handler methods have always been local to the controller or the controller hierarchy. And that makes them not very well suitable for handling exceptions across the board. So we want a strategy for being able to write error details to the response body, but we want to be able to do that throughout the application. And this is now possible, and the way that it's done is by providing @exception handler methods not in a controller, but rather in a class annotated as controller advice. When you have a class annotated in this way, it effectively all of its methods, which can include @exception handler, @initbinder, and @model attribute methods, become globally applicable to all controllers. So that means that we can write such a class as long as it's registered as a Spring component, and it will be discovered through component scanning because controller advice is a component annotation. These global exception handler methods will just work. The use case for global initbinder method is if you want to apply some sort of customization to the data binding throughout the application. And that will be something that can be done with controller advice as well. The next topic is matrix variables. Matrix variables this is a new annotation which is available in Spring MVC, and essentially they are about processing parameters in the path of a particular path segment. So for example, here we have /pets/id, and the last path segment happens to have a parameter attached to it. These parameters can be present in any path segment, and there can be any number of them. And the way to deal with that now in Spring MVC is, first of all, wherever we expect semicolon content to use a URI variable in order to encapsulate all of that content. And then we can extract both the path variable itself, which is the value, in this case 42. That's the actual path variable, path segment value, as well as the matrix variables, which we can do one at a time in a way that should be very familiar if you already understand the other annotations in Spring MVC. There is some configuration which is required in order to enable processing of semicolon content. This is because we don't want to disrupt existing applications which have always worked in a certain way. However, if using the MVC Java config or the MVC namespace, this is enabled automatically for you. So it's a bit more of an aggressive upgrade there with the MVC namespace and MVC Java config. And for more details, follow this link to the reference documentation, and you will find out how and what needs to be configured. And the other topic that I want to cover today, there are other smaller items. I recommend taking a look at the reference documentation to see the What's New section for a few other items like support for Tiles 3, support for Jackson version 2, the Jackson JSON library. We also have support for generic arguments in @response body methods, as well as with the REST template when returning things like collections. So I encourage you to take a look at some of the smaller items. But one of the last large item I want to cover is testing. And the first on the list in the area of testing, in the Spring Test module, we have support now, official support for web applications in the test context framework, which essentially means that we can now use the web app configuration annotation. And that indicates to the test context framework that what we want to load is actually a web application context. That's the type of the application context we want. And it's going to configure the resource path for the web app. So for example, in order to create a web app context, we also need a servlet context. And the mock servlet context is what's going to be used. And by default, we're going to assume that the files for the web application are located in source main web app, so that if at any point we try to look up any resources of the web application through the servlet context, they will be discovered correctly. Building on that is actually a new addition in Spring Test, which is specifically focused on Spring MVC for the first time. So we have lots of very good general web application support through the mock request and response. But now we have dedicated support for testing Spring MVC applications. And as you are probably quite familiar, the way to write tests for Spring MVC controllers today is to essentially create pure unit tests where a controller is instantiated and injected with mocks, and then its methods are invoked directly. And of course, what is not being tested with this approach is all the annotations which are on the controller, like the request mapping annotations, the model attribute, the data binding, the validation. There are tons of things that are being done by Spring MVC which do not get tested if you invoke the controllers directly in this way. So with Spring MVC Test, we have first-class support for testing in Spring MVC applications, and it has been a very popular feature so far. We have a Fluent API for performing that, which we'll see in a moment. The server-side tests involve running the actual dispatcher servlet, which means that the actual annotations are going to be processed. And then on the client side, we're using the REST template for testing applications that use the REST template. The server-side builds on the mock request and response, and that means that essentially the servlet container is not required to perform these tests, making them a little bit faster. And you will see here a tweet which I decided to use. There's a small discussion there about whether Spring MVC Test is actually a unit testing framework or an integration testing framework. And the answer to that is that, well, these are integration tests for sure. There's a lot more going on than just instantiating a controller. We have a dispatcher servlet. We're loading Spring configuration. So that's definitely integration on the side of integration testing. However, probably the reason why the author of that tweet said unit testing is because there is kind of a unit testing feel. First of all, there's no servlet container involved. The mock request and response are being used. The controllers can still be injected with mock objects, which means that we can focus very specifically on the web tier as we did before with the unit tests, except now the controllers are being fully tested. And there are actually two setup options which are available. The first one is to load the Spring configuration as usual with the Spring MVC handler mappings, handler adapters to be discovered by scanning the Spring configuration. And the second option is a standalone setup option, which means no Spring configuration is loaded. You basically just instantiate your controller, and that gets invoked through the dispatcher servlet. So I would call that, the best way to see that is look at your existing controller unit tests and think about writing those using the Spring MVC test support. So it's kind of a unit testing plus plus. It's just a specialized support for controllers and the web tier in Spring MVC. Here's an example of server-side test using the web application context setup. Here you see the use of the web app configuration annotation, as well as we're pointing to a specific application context where our Spring MVC configuration lives. Then we're injecting the actual web application context configuration into the test. And then in the setup method, we're using that to create an instance of a type called mock MVC. And that's the main type that we're going to use for the testing. In the actual test, you will see the Fluent API used. So we're going to say this MVC perform a GET request for /foo using the application JSON accept header. And then after this is performed, we're going to expect a response of 200 with a content type of application JSON. And we can actually also apply JSON path and XPath on the response to assert a very specific outcome in the body of the response. On this slide, you will see the standalone setup, which does not involve any Spring configuration. We're simply pointing to a controller. And the result of that is something very similar to the Java MVC Java config. You just basically get support for annotated controllers. And the dispatcher servlet is still involved, so you can still do your testing, but there's no Spring configuration involved. And the client-side test is basically for applications that use the REST template. The idea is that we can instrument the REST template with a request factory, which doesn't actually go to a server, but only verifies that the expected requests are being performed. That's basically an example of using it. We're going to set up the expected requests, and then we're going to basically just use the REST template and at the end verify that all the expected requests were actually performed. And you can see some resources on Spring MVC Test. There is a blog post, and there are sample server and client tests in the framework itself. I've provided links for that. The Spring MVC showcase has been completely outfitted with Spring MVC tests, so you can take a look at a fairly extensive set of tests over there. And the reference documentation has a chapter on Spring MVC Test that you can take a look at and get a better idea from the top down. And with that, I'm going to turn over to Chris Beams to talk about some of the exciting changes around community and contributions that allow you to participate in the process better and more effectively. Communicate with us. Thank you.
Hi, thanks, Ross. And my name is Chris Beams. I'm a staff committer with the Spring Framework as well. And I want to talk about some of the community aspects of the framework, specifically contribution, ways to contribute. And this is a relevant topic because there have been quite a few changes over the last year or so. Juergen already mentioned that we've moved to Gradle. So that's one big change away from our Ant and Ivy-based build. As you also may know, we've moved from our own self-hosted Subversion arrangement to Git and hosting at GitHub, which has also made a big difference. I'll talk a little bit more about each one of those in a moment. And you may have also noticed that we now have a dedicated artifact repository based on the Artifactory product at repo.springsource.org. And you'll see the FAQ there that can give you all of the information you would need to know about downloading artifacts from there using Maven or other build systems, particularly how to get hold of our milestones and snapshots and release candidates and so on. And again, all of these links are in a separate document, the URL for which we've already put in the chat, and I'll be showing that again at the very end of the presentation. So this is just a screenshot of the SpringSource organization at GitHub, which again you may have already seen. If you haven't, it's really worth a visit because it's something like one-stop shopping, not just for the Spring Framework, but for really all of the Spring family of open source projects. They're all hosted in one pretty convenient location now, so there are quite a few repositories. We're just filtering for those that match Spring Framework. And you can see some interesting statistics there, right? The 1,400 or so stars indicating, people's interest in the Spring Framework. So people who want to, for example, be notified or just pay attention when commits are made to the framework. They want to kind of track what's happening in development. That's an option if you're interested in that. And next to that is the number of forks, which is upwards of 600, which is a number that indicates people who have actually, they're not just paying attention to the source, they've actually created their own fork of the Spring Framework, which tells us that they're probably building from source for some reason, maybe just exploring, or of course, maybe doing some real hacking, some local changes, trying to maybe fix a bug, even contributing those changes back to us, which I'll talk about in a moment. So a year later, a little over a year later, since that move to GitHub, like I say, 600 plus forks, and out of those forks, at least 200 or so people have issued pull requests. I'll talk a little bit more about pull requests in a moment, but that's essentially, if you aren't familiar, like a patch, but much better. A very nice streamlined way of contributing code to an open source project. There's really a reason that GitHub has been so successful, many reasons, but this is one of them. They truly have a better model for contributing to open source, and we're quite glad that our users can take advantage of that now. So that's definitely one way to contribute, right, is contributing code. But there are more ways to contribute, and I'd just like to go through what we see those as being, if you're interested. And the first one that should be mentioned is simply answering questions for the rest of the community. Probably most of the people on this call are familiar with the Spring Forums at forum.springsource.org, which have always been around and are now and always will be. But it's a good time to mention Stack Overflow if you haven't been paying attention to.
Our speaker will be rejoining in just a moment.
Okay, I'm back. Sorry for the delay. So I was just saying many ways to contribute, and we should talk about Stack Overflow here. If you're not familiar with Stack Overflow, it's really a great site for general question and answer around programming topics, certainly including Spring. And this is just a snapshot, again, a screenshot of some of the tags that include Spring in the name, and you can see some of the statistics. Pretty representative. This was taken just today. 305 questions against the Spring tag this week, with 60 of those happening today. That's pretty representative of what you would see on any typical day or week at Stack Overflow. So that's a really vibrant community. And aside from just helping your fellow developer with answering questions, of course, that's a way to build your own reputation as being someone who knows something about Spring to participate there. So we certainly encourage it. And thanks for those who already do. The second one is might be an obvious one, but submitting bug reports, simply because if you find something that's not working the way that you expected and you don't let us know about it, well, of course, we can't fix it. So thanks to everybody who submits, and please keep that up. We receive, on average, over 1,000 issues every year against our Jira issue tracker, about 1,100 or 1,200 over the last year. Of course, some good portion of which are bug reports. And yeah, we really appreciate all of that activity on Bug Tracker. That's definitely contributing from our point of view. And the third one is tracking our snapshots, milestones, and release candidates. We're always working on the next version of Spring. Juergen will be talking in just a moment about our plans and the development that is indeed underway for Spring Framework 4.0. And we'll have a first milestone for that out soon enough, probably around April. We very much appreciate it when you guys try out those features as early as possible and give us as much feedback as possible. That, of course, helps us ensure that we put together the best possible GA when it is time to go into a final release. And then, by the way, that same wiki link that I gave earlier and that, again, we'll give at the end, describes how to download, how to track those milestones. Again, using Maven or whatever your build system of choice is, grabbing those things from the Spring Source repository where we publish them. And we publish snapshots not only every day, we publish snapshots every single time we commit to the repository. So our continuous integration server is indeed continuously publishing. This is nice to know if you're a reporter of an issue. If you've reported a bug, for example, and we mark that bug as resolved, that means that that fix will be available probably just minutes later, as soon as the next CI build plan finishes. So you really can try things out immediately. No need to wait for the next point release or the next milestone. And of course, we appreciate the feedback that you tried out and let us know that it was the fix you were looking for. And that brings us back to the fourth way to contribute, being contributing code. And if you haven't ever done this before, you might wonder, why do people do it? Some answers are obvious: to scratch your own itch, if you will. You find something that you think could be improved in the framework. Certainly, the fastest way to make that change happen may well be to do it yourself. Right? We really pay attention when someone comes to us with working code that says, "Hey, this is the bug, and here's the fix." And you'll see the link to the contributor guidelines in a moment that explain exactly how to do that. And the contributor guidelines it's a useful document because it describes pretty closely actually how we develop the framework. So if you're interested in doing that, of course, you'd want to know about those instructions, right? The second reason is simply because there's no better way to get more familiar with the framework. If you use Spring every day and you want to know more about it and just build your own expertise, hacking onto bug fixes and minor improvements and so on is there's just no better way to build expertise. And of course, this is another way to build your own reputation. There's no better way to tell the world that you know something about Spring than having your name in the commit logs. So encourage all of that. And the good news with contributing code is that it's never been easier because of these recent changes, particularly around Gradle. Downloading and building the framework from source is just that simple, right? It really requires only having Git and JDK7, since that's what we build against these days. And once you've done that, the building from source instructions and the link you see there are really quite straightforward, just a couple of commands. And if you do put together a change and put together a pull request, again, there are the contributor guidelines to follow. And this is a nice place to mention, as a bit of an aside, a different repository, not the Spring Framework repository proper, but the Spring Framework issues repository is something that we've put together relatively recently. This is another way of contributing code, even though it's not to the core framework. If you find a bug, the best thing you can do is to contribute a working reproduction project that demonstrates that bug. And this is, again, something that we naturally give priority to when we see those, because it's so easy for us to reproduce for ourselves the failure. We can just run your code. And you'll see at that repository and the README there that there are template projects that make this very straightforward, templated out simple Maven projects that you can just put your working or failing code, right, the thing that demonstrates the bug, and again, issue a pull request against that repository, and it gives you links to understanding pull requests and so on if you've never done that before. So in general, the communication here is that contributions are really welcome, and we appreciate all those that have come so far, and we look forward to even more of them in the coming year. And to that end, we've actually just made a small change to our Jira issue tracker, which is that we now have a dedicated version, actually, a fixed version in Jira called Contributions Welcome. And this is just a way for us as the staff committers to set a flag, if you will, or kind of a way of telling the community, here's an issue that's a valid issue. We've triaged it. It's completely worth being fixed or being addressed, but it doesn't have priority for us right now. It's like nice to have. And it's something that an outside committer could probably put together without too much trouble. You wouldn't need to know too many things about the framework to put together a reasonable pull request. So if you're interested in contributing, that's a place to look, and you can see a query here in our Jira issue tracker where the project is SPR, that's the Spring Framework project, and the fixed version is Contributions Welcome. At this point, there's only a handful of issues in there, but we expect that will grow as we incorporate this into our own process. So, of course, if you already know what you want to work on, you've found a bug and you'd like to put that together, just communicate with us in a normal fashion over Jira about that. But if you're actually looking to pick up some open source work and work against the Spring Framework, this is a way for you to do that. And finally, from my side, just once again, a big thanks for everybody that's been contributing in all the different ways that you do. And a few links for you, if you're not already aware of these, ways to stay in touch with us, ways to see what's going on in the community, whether it's via Twitter or the Twitter handles of the individual Spring Framework team members. Many of you probably got here today via the newsletter. If you don't know about that, there's the link for the newsletter. We have some quite nice things in there lately, really useful tips and tricks and so on. So I'd encourage it. And finally, we started a Google group not too long ago, specifically dedicated to people who want to contribute. So a kind of dedicated place to talk about, here's a change that I'm thinking of making, or I don't quite understand this subsystem. Can you help me out a little bit? Again, specifically for people who are wanting to contribute. And of course, the Spring Source block, which I'm sure everybody knows about in one way or the other. And that's it for me. I'll hand it back over to Juergen, who will give a bit of an outlook for the coming year. Thanks.
Thanks, Chris. It's my pleasure to do a bonus section on this webinar. And this bonus section is basically a plan that's been in the works for a while. We unveiled the plan just this week. We're talking about the next iteration of the Spring Framework. And after spending basically 3 iterations on the Spring Framework 3 generation, we decided on a number of very relevant, very up-to-date themes that we expect to make their way into the enterprise in 2030. And given the amount and the depth of those issues, we decided that the next version that we're working towards would be Spring Framework 4.0, and I'll be going into why a little bit in a moment. But let's start with the most obvious, most important themes that we are incorporating into Spring Framework 4. We have Java 8, Java SE 8 upcoming this year. OpenJDK 8 is making steady progress, maybe slightly behind schedule, but not much. There's going to be an OpenJDK 8 developer preview to be released in late February. And from our perspective, OpenJDK 8 is something to really look forward to. We will be getting new language features, most importantly, Lambda expressions, also known as hookup closures. Lambda expressions are particularly important for a kind of callback-oriented programming style, such as the style that we've been introducing years back with like GMS template and so forth, where you're passing callback implementations into GMS template execution methods. It's exactly this sort of programming style that Lambda expressions have been designed for. And with asynchronous programming, the decomposition of processing logic into smaller, fine-grained units, we'll see even more of that style of code. So Lambda expressions come, from my perspective, just about in time to be truly useful for the industry here. Wouldn't have minded getting them earlier, but better this year than never. So it's not just Lambda expressions with Java 8. We're actually looking forward to quite a few other features in Java 8, one of which I've mentioned here. That's the JSR 3.10 date and time APIs. Basically, a Java util date, Java util calendar replacement. And that's really so overdue, it almost hurts, right? We've been working with the 1996 style, slightly broken Java util date and calendar arrangements for so long that we probably don't think about it too much anymore. But we really need good date and time, properly designed date and time types, expressive date and time types, for use in the very heart of our domain models. And JSR 3.10 is providing exactly that as part of Java 8. It's been run by the same person that also runs Joda time, so it's basically a Joda time, standardized version of Joda time of some sorts, but significantly different in the details. You can expect full support for the JSR 3.10 types very soon this year in a Spring Framework 4.0 milestone for the purposes of data binding and any other purposes that you might need them for in your domain models. All right, next to the Java 8 topic, we also decided on a reinvestment into Groovy. You might be aware that Spring has been shipping Groovy support for a number of years. There's the Lang Groovy element, Groovy scripting support, basically. Of course, Spring Framework is used as a foundation for the Gradle framework, all Groovy-based. So things work quite fine the way they are. But with the advent of Groovy 2, Groovy 2.0 last year and Groovy 2.1 very soon this year, we really have an opportunity to revisit Groovy, not just for scripting purposes in isolated corners of the application, but rather for broad use of the Groovy language across the main sources in your application, possibly even for the entire application, basically replacing Java sources with Groovy sources in some way. Groovy 2 has a static compilation mode for the first time, so it really comes very close to a kind of Java replacement with dynamic elements, if you want to look at it that way. So that's one important area of work. And there's Java EE 7 upcoming. Java EE 7 has been delayed several times. It should have been out way back, but it will be coming in Q2, towards the end of Q2 this year. So we expect to have it by June or so. Java EE7 provides or includes some key technologies that are really important to the Spring programming model, such as an update to GMS, a really overdue update to GMS, GMS 2.0, the first GMS release since like April 2002. So it's actually in more than 10 years, the first reiteration of GMS. But also JPA 2.1, Beam Validation 1.1, a minor revision of the Servlet specification, Servlet 3.1, all of which we are tracking, all of which will provide support for in Spring Framework 4.0, primarily for embedding into Spring applications. So if you're embedding a Beam Validation provider, a JPA provider, or a JMS driver, you may choose to use the very latest releases, the very latest API versions there. And as a new element in the EE space, we have JCache, basically an already referred to standard for caching purposes, for cache interaction, a little bit of a backend cache abstraction in there as well. And we're already providing early support for this in 3.2. We'll be providing full support for JCache 1.0 final in Spring Framework 4.0. So the timing is a particularly important aspect of this. We are really tracking specifications, lines of work that are really important to us. Those lines of work reaching an important state this year, and us tracking them very, very immediately after. Another, not really line of work, but rather a technology area that this industry is exploring is WebSockets and WebSocket-style application architectures, a different way of designing the interaction between your web clients and your server backends, more messaging-oriented and using a basically WebSocket protocol upgrade from HTTP. We are tracking the efforts there, both the efforts in the JCP in the form of JSA 356 and also related technologies allowing for the style of architecture in a slightly different way. We are basically working on incorporating elements for WebSocket-style application architectures into Spring, into the Spring web support, even going as far as a backend, an endpoint model basically for WebSocket-style interaction running on a Spring-based server system. Related to this, but only slightly related technically, we have a focus and basically another reinvestment into eventing and messaging in a form where we are revisiting our own application event mechanism, our own message listener mechanisms, and are trying to provide a fresh, very concise approach towards designing like a high number of fine-grained endpoints in your application, where you're not interacting with just a very few GMS destinations somewhere out there in your enterprise, but where you're rather using GMS or a local eventing mechanism for very fine-grained interaction, even within your system, even within the VM. So this also goes strongly into message-oriented architectures, asynchronous processing-oriented architectures, and we'll do our share in revisiting our own core mechanisms there. Finally, a really important area, a really important task that we only get to very rarely is pruning, basically going through the framework, removing outdated features, outdated packages. We tend to keep up support for older versions of external libraries very long. We are using the opportunity now in Spring Framework 4.0 and we'll be removing everything basically that's deprecated now in Spring Framework 3.2 is scheduled for removal in Spring Framework 4.0. So there might be a few further implications of the pruning efforts, but it's primarily for getting rid of things that have been deprecated for years already. Another related area here is dependency upgrades. you'll be seeing a few minimum dependencies bumped up. In particular, will require Java 6, not only Java SE6, but at least as a reference level, also Java EE6, with only minor compromises made for EE5 service with EE6 feature packs. So in case you're using recent WebLogic 10 versions, or if you're using WebSphere 7 with the JPA 2.0 feature pack, you'll still be served. Spring Framework 4.0, according to the present plan, will still work for you. But as reference level, will be Java EE6 based. We'll also revisit external third-party open source libraries such as EdgeCache, Quad, and so forth. So we'll also raise the minimum versions required there. We will be able to provide more specific support for the latest features in, for example, the EdgeCache 2.5 that way. So you'll see some fresh air going through those support packages as well. All right, that really is the Spring Framework 4.0 plan that we start working on basically now, that we've been designing for a while and actually starting to execute on now. Chris already mentioned that there will be a Spring Framework 4.0 milestone 1 in April, late April. So we are tracking OpenJDK 8's developer preview, and we'll be releasing a first version of Spring Framework 4.0 very soon after. We are targeting a 1-year iteration here after Spring Framework 3.2. So our plan is to go GA, to provide a generally available version of Spring Framework 4.0 in Q4 this year, towards the end of 2013. All right, that is really all we have for today. We might be able to take a question or two on the audio streams. Otherwise, let me just state that please provide us with your feedback. Use all the channels that we have. Chris was showing quite a few of them before. If they are Spring Framework 4.0 related, feel free to post comments to my recent blog post on the Spring Framework 4.0 plan. We'll be very responsive to any feedback coming, and we'll certainly incorporate quite a bit of community feedback in this Spring 4.0 plan as we move forward with it. Okay, there's a whole series of questions in here. I'm actually trying to find a few that might be particularly interesting for the audio stream.
Juergen, while you do that, maybe I will just briefly answer a couple of questions.
Sure, please do that.
There have been a few questions around the async support. For example, how does it work internally, as well as around its configuration, whether the long polling, the length of the long polling can be configured, and so on, about the thread pool, etc. The implementation, essentially internally, Spring MVC does nothing more than delegate to the Servlet API. And the value that it provides is essentially making the async support in the Servlet API available within the annotated Spring MVC programming model, so that you can simply return a callable or a deferred result, and things should just work from there. And there's lots of other things that we don't have enough time to discuss here. For example, what's the impact on handler interceptors, on exception handling, thread locals, etc. All of these things have been carefully considered to make sure they work. So essentially, this is first-class support on top of the Servlet 3 API. And you can look at the section with resources. There's actually a 5-part blog series which explains and provides a lot of background. The reference documentation has a chapter. So all of that should give you a pretty good start. Of course, reading up a little bit on the Servlet API as well might help, but you can start with the provided resources. As far as configuration, yes, there's a number of things that can be configured through the MVC namespace, the MVC Java config, or even without them. You can configure the thread pool. You can configure the timeout period for asynchronous requests. and there's a few other things you can do as well. So please take a look at the resources, and hopefully that will give you the answers that you need.
There is a line of discussion here that I'd like to quickly pick up, which is the notion of backwards compatibility. Note that we take backwards compatibility very seriously. We always have, we still do. The idea with removing deprecated packages is simply that we have to, just trim a little bit of the support fat that we've been accumulating over the years. So it's not about removing functionality. It's about removing support basically for third-party packages, for third-party libraries, or for older functionality in Spring that has seen a replacement years ago usually. So we're basically, for example, removing the old form controller hierarchy that has been superseded by the @MVC @request mapping model in like 2007. We are removing support for older generations of the edge cache and quartz that we really expect everybody to upgrade to the newer generations by the end of next year. We are removing some support that we historically had for the EGB2 generation that simply doesn't have much of a place anymore these days. We are removing support for JAX RPC, for example, a standardized API that had a replacement with another standardized API in JAX WS. So we are following deprecations that some third parties have been doing to some degree. We're doing some deprecations of our own, but it really shouldn't be disruptive to what you are doing. So I would expect any application that has Spring application that has been designed in the past 3, 4, 5 years to basically be able to just move forward as is. You really shouldn't see any disruptions. In terms of the functionality that is going to stay around, right? All the Spring functionality, this 99% of what we're doing that is going to stay around. We are really trying very, very hard to be 100% backwards compatible for all of that. So an upgrade for a typical Spring 3.1, 3.2 based application to Spring Framework 4.0 should just be a drop. It should be a drop-in replacement. There shouldn't be much need to touch or any need to touch your application artifacts. However, if you upgrade to Spring Framework 4.0, hopefully you will find plenty of good reasons to actually use Spring Framework 4.0 specific functionality. That, of course, is the whole point of why we are doing it. There have been a few further questions related, for example, to Groovy. Groovy, of course, is an important, just very briefly, Groovy is an important part of our wider ecosystem and has seen plenty of adoption through Grails in particular, already running on the Spring stack. So some of those efforts are basically about aligning with the fundamentals of what Grails is doing. We'll be working closer with the Grails teams, taking some functionality such as the Gradle-based beam definition builder in Grails, and we'll be adding this basically equivalent functionality to Spring Framework proper. So quite a bit of that work isn't actually brand new. It's basically incorporated into Spring Framework, coming from other sources within our ecosystem. And some of it is, of course, new, where we're exploring the static compilation mode, the wider spread use of Groovy source files in a typical Spring-based application. So it's not about redesigning your application. It's not about an opinionated web framework or anything like that. It's a traditional Spring-based architecture, just basically implementing quite a number of, or even all of your Java source files with Groovy instead. That's a line of work that we're exploring. It doesn't really come as a strong recommendation of any sorts. We want to provide a little bit of a polyglot experience here. If you're running on Java 8, basically use the brand new Java 8 language features if you can, or choose to use Groovy 2 features, the very latest Groovy 2 language features, if you want, right? Spring will be there to basically serve you, to have anticipated the little interaction issues that might be happening otherwise. So if you're going to use Spring Framework 4, you should see a very smooth experience either way, with Java 8 language features, with Ruby 2 language features. So just for clarification, the framework itself will, of course, be implemented in Java as always, right? Built on OpenJDK 8 and compiled with Target 1.6 will be compatible with Java 7 and Java 6 still. The Groovy support is basically designed for interacting with components that you're implementing. It doesn't affect how the framework is implemented. There is a question that comes up repeatedly, and I'll just point you. It's the question about the conversation scope, a conversation scope model, conversation demarcation, and usually it's also about window-specific sessions in the browser. This is a question that comes up repeatedly, and I will actually provide an update on that, a statement basically on our position there very soon, since it also came up against the Spring Framework 4.0 announcement on the blog. It's a little bit of a more involved question, so I'd rather like to take it offline here. So let's see whether we can maybe take a final question. Just scrolling quickly here.
I'll just weigh in quickly. This is Chris again. There were a number of questions.
Yeah, sure. If you found one, please take it.
I'm taking a number of people asked about the build and why did we make the choice to move to Gradle versus the quite natural question to ask, why Gradle instead of Maven, or why move away from Ant and so on. And of course, it's a bigger topic, but just to answer it quickly, it's essentially based on experience. We've actually been through building, of course, with Ant and Ivy for a long time across multiple projects. And we've also built with Maven. Some of our bigger and more important projects like Spring Integration. And it simply turns out that while Maven is actually perfectly well suited to a particular class of Java application, that which you might call a typical Java application, can often get by just fine with Maven. We aren't exactly a typical Java application. We're a framework, and there's a lot going on in there that's actually pretty custom. And we just found through experience that Gradle was really an elegant solution to many, if not all, of those problems. And it's worth mentioning a couple of things on the Ant and Maven front. One, we actually haven't quite left Ant altogether, because Gradle actually has dedicated support for Ant. So actually some of our Ant logic is still around, now kind of translated into Groovy's, Gradle's kind of Ant syntax. And then the other thing is that our own internal choice to use Gradle has nothing to do with our commitment to publishing Maven-compliant POM files. We have done that, we do that today, and we'll continue doing that into the future with 4.0 and beyond. So don't worry a bit. Our choice to move to Gradle doesn't mean that you can't use Maven, if that's a concern. You can continue using any build system you like to consume Spring Framework artifacts. Just thought I'd mention that.
All right. I just I'm picking one last one for the session here for myself. It's the question about JCache. Maybe I should quickly clarify what JCache really is. It is a JPA-like specification, like the Java Persistence API, that basically defines a kind of interaction layer with a backend caching system or a caching-like data store. So it's basically an abstraction. And EHCache is kind of the reference implementation, not technically, but effectively, since the very same person leads the EHCache project and is the spec lead of JSL 107. So from our perspective, we keep up direct the edge cache integration. Primarily, well, if you haven't been using Jcache up to now, why should you if you're happy with setup? There's also ways of fine-tuning the interaction with the edge cache, of course, that goes way beyond what the Jcache specification defines here. So in that sense, it's a little bit like with JPA and Hibernate initially. You'll find both ways of setting up your caching arrangements in Spring. If you want to use Jcache, in particular for commercial cache providers that are Jcache compliant or will be Jcache compliant, then that's a good way of doing it. If you've been happy doing it directly against the edge cache, for example, that keeps being perfectly okay. Just like you might choose to use the native Hibernate APIs, even if there is JPA, right? So it's a bit of a similar decision to make. All right, I think we're reaching the end of our time frame here. So thanks for your participation. Thanks for joining. Thanks for staying online for the Q&A part. Keep the questions coming on all the channels that we're providing. And the webinar will be published soon, as initially announced. So you can also review the contents of the webinar if you want. Well, thanks for attending. Cheers. Bye-bye.